Okay, this lesson is all about proportion. And two things are said to be proportional if one changes steadily when the other changes steadily. So for example, here you've got values of x, 1, 2, 3, 4, 5, 6, 7. And the values of y are 3, 6, 9, 12, 15, 18, 21. So x goes up steadily by 1 every time, and y goes up steadily by 3 every time. So those two things are proportional. And if you think about that, you can realize that the relationship is that y is 3 times x. So in fact, anything where the relationship is y equals something times x, and I've called that something k here, then the two variables are proportional in that case. And k is just some number that's appropriate to the relationship. So here's another example, y equals 7.5 times x. If you do a table of values, when x is 1, y is 7.5, when x is 2, y is 15, so on and so on and so on. And you can see that as the x's go up steadily by 1 every time, then the y's go up steadily by 7.5 every time. So they're both going up steadily by a particular amount every time. Now sometimes you see a situation where one of the variables is proportional to the square or the cube of the other thing. So for example, something like y equals 5x squared. So in this case, when x is 1, y is 5. 5 times 1 squared. When x is 2, y is 20. 5 times 2 squared. Remember to do the squaring before the times. When x is 3, y is 45. 5 times 3 times 3 is 45. And so on and so on. So in this case, you can see that the y's are going up by a bigger amount every time, because when you calculate the y's, you're squaring the x's. So here's an exam type question. R is proportional to the square of S. When R is 90, S is 6. Write an equation connecting R and S. Well, you need to set this up in the right way to start with. It says R is proportional to the square of S. That means that R and the square of S, S squared, have some kind of a relationship. And it says R is proportional to the square of S, so that means R is something times S squared. And I've called that something K. So R equals some number K times S squared. Now we've got more information there. It says when R is 90, S is 6. So we can put those numbers in. So R is 90 and S is 6. So 90 is K times 6 squared, which is the same as 36 times K. 90 equals 36 times K. So we can actually figure out what K is by dividing both sides by 36. And K's 2.5. So the equation connecting R and S, well, we saw in general terms it was going to be R equals something times S squared. And now we've figured out what that something, that K, is. We can say that the relationship is that R equals 2.5 S squared. So the equation connecting R and S is R equals 2.5 S squared. Now sometimes the two things can be inversely proportional, and one of them is going to get bigger as the other gets larger. Sorry, one of them is going to get smaller as the other gets larger. And those are, well, for example, y equals 4 divided by x. If we do a table of values for that, when x is 1, y is 4 divided by 1, which is 4. When x is 2, y is 4 divided by 2, which is 2. And keep calculating those. And then you can see as the x's go up, the y's get smaller because we're calculating the y's from dividing by a bigger number every time. So generally speaking, those kinds of relationships are y equals something divided by x, some number k divided by x. And here's an example of a question you could get on that. T is inversely proportional to v. When t is 8, v is 2. Write an equation connecting t and v. Well, it says t is inversely proportional there, so that means the relationship is going to be t equals something or other divided by v. Now we've got some information there. When t is 8, v is 2. So we can put those numbers in. 8 equals some number k divided by 2. And we can figure out what k is. Multiply by both sides by 2, and we get that k is actually 16. So the relationship between t and v, well, we know that it's of the form t equals something divided by v, because they're inversely proportional, and we've just worked out that that something is 16. So t equals 16 over v is the equation connecting t and v. What is the value of t when v equals 20 could be another part of the question. Well, we know that the relationship is t equals 16 divided by v, because we just worked that out. So we can just put 20 in and find out what t is. So t is going to be 16 divided by 20, which is 0.8. Now, here's another type of question. M is inversely proportional to the square of z. So that means there's some relationship between m and z squared, the square of z. And if they're inversely proportional, that means that the relationship is m equals something divided by z squared. So that's the general relationship, and we've got to find out what that number k is that links m and z squared in that relationship. And we can do that using the facts they've given us, that when m is 3, z is 2. So we can put those numbers in and say that 3 equals k divided by 2 squared, just replacing m and z with 3 and 2. Well, we can work out k from that. 2 squared is 4, so it's 3 equals k divided by 4. Multiply both sides by 4, and k is 12. So the general form of the relationship between m and z was that m equals something divided by z squared, because it was inversely proportional to the square of z. And we've just worked out that that something is 12. So the relationship is that m equals 12 divided by z squared. That's the equation connecting m and z. So another part of the question might be, what is the value of z when m equals 48? So take the relationship between them and put in the number that we're given. So the general relationship is m equals 12 divided by z squared, and we can put that in. So m is 48. 48 equals 12 divided by z squared. From that we can figure out what z is. If I multiply both sides by z squared, I get 48z squared equals 12. If I divide both sides by 48, I get z squared is 12 over 48, which is 0.25. So z squared is 0.25. So z is the square root of 0.25, which is a half. Z is a half. So when m equals 48, z is a half. Okay, so there are some questions on this. There's a sheet, and have a go at those, and there will be a video with the answers on.